Hi, this is Kevin. Welcome to my Beyond the Textbook lecture associated with the Chapter 8 of the Zelle 3rd edition Python book. And this chapter was about loop structures and Booleans. Okay? And first of all, let me show you. We have a project that's available for you to download in your weekly schedule for the course, demonstrations to supplement Zelle 3E Chapter 08. Okay, so these are the examples I'm going to be talking about in the lecture, and you can download them and open up the PyCharm project and play along if you would like. So one thing that's not specifically emphasized in the Zelle chapter is the extent to which the for in construct, which we cover in previous chapters, most notably chapter 5, is the preferred Python looping structure. Okay? It's the go-to solution. Why? Well, it's supported by all the Python iterable types that include, these are the ones that we've been using, string, list, tuple, range, and file. And it's a no muss, no fuss kind of solution. One of the nice things is that it handles any number of items in the underlying data structure. So any number of characters in the string, any number of items in the list, any number of lines in the file. Okay? It even behaves appropriately when the data structure is empty. So empty string, empty list, empty file. Okay? So I think your first thought ought to be, can I do this with a for in? Okay. Now, having said that, the while is a better choice for some looping use cases. And what I'm trying to do in this Beyond the Textbook lecture is to highlight them. Okay. So I'm sure there are more, but here's the ones that I would like to call to your attention. The first, interacting flexibly with the user at the console. Okay, we're going to do that with the Sentinel loop. That's implemented with a while. Searching a file for the first matching value. Okay, that's better implemented using the pattern for the Sentinel value. Again, that's implemented with a while. Processing records from any data store that does not support for in. So a data store that is not a Python iterable. Okay. And that's a little bit hard to demonstrate in our course because the only data store, and by data store, I mean some object in which we can store data in between executions of our program. So that's a file, a database, something like that. It's non-perishable storage, right? So there are some data stores that do not provide an iterable interface for Python. And we're going to talk about, well, what kind of logic would you use for that? It would include the while. Simulating gameplay, okay? That's something that we typically do when we're trying to practice writing a complex program, and that is really well suited to the while. And controlling devices. I'm going to show you some code that I have that controls the star on top of my Christmas tree. And it has a while loop in it. Okay, so that's what we're covering here. Let's proceed. So, interacting flexibly with the user at the console. The preferred design pattern for flexible interaction using the console is the Sentinel loop, implemented with a while. So we're going to look at two versions. We're going to look at O5 flexible user interaction using while, okay, and O8 recovering from bad user input using while, which is kind of our final version, okay. So let's look at O5. Okay, so um, uh, in this series of demonstration programs, I would say that my doc strings are a little on the chatty side. Okay, we're probably more here than you would need in a program that you would write in your day job because I just want to emphasize a couple of my teaching points. Okay, so we're going to demonstrate flexible user interaction using while. This program uses the Sentinel loop. It implements the flexible integer adding machine. So what we're trying to do, we've been kind of building adding machines as we go through the course, and the first ones were very crude and they were not very user friendly. And this one's going to be more user friendly. Okay, so how's this one going to work? Well, let's run it first and explain it second. So it begins by welcoming us. Please enter an integer value to be added, just the enter key to stop. So let's just hit the enter key. And it says the sum of 0 entries is 0. So it was able to detect that we didn't give any entries at all. Okay. All right. So let's give one entry, 999. Enter. Enter again to stop. The sum of one entry is 999. Well, that's good. And let's just give 3. Okay. 111, 222, 333. Plain enter to stop. 666. All right, that looks good. Now, is this program able to recover from bad integer input? It's not. That's what the second version is going to show us. Okay, so if we run this, and at any point, instead of putting in a proper int, we type hi mom, it's going to blow up. Okay, so that's not as user friendly as we'd like it to be yet, but we're showing the use of while for a Sentinel loop, and we're showing how we can design it to be pretty user friendly, although not as user friendly and robust as we want to eventually get. So we come into the code. We print sort of an introductory title. We initialize a count of the entries, initialize the sum of the entries. Those are both ints. Okay. And then we have the cleanest thing to do when you're using a while to read input is to always have a priming read as the last of your initialization actions. So typically you have a priming read as your last initialization action, and then you have another read at the bottom of the while loop. Okay. Now, historically, I haven't worried too much about the fact that they were duplicate code, but in trying to teach you the best practices, I have taken the solution that I used to use and refactored it such that uh, from both of the places where we want to get input from the user, we call a function called get input from user, and it's that function that prompts the user, please enter an integer value to be added. Okay? Um, and the while is going to continue until it says while entry as string is not equal to the empty string, which means uh, we haven't had the user press just plain enter, so that's going to signal the end. Okay, so the nice thing here is because we have the priming read, uh, if we have gotten a just a plain enter on the first entry, we're never going to do the work in the body of the loop. Okay, and the work in the body of the loop is we try to turn the text that we got into an int by calling int. Uh, we we bump up the count of entries. Uh, we accumulate uh, the entry amount, and then we uh, read again, which you always do at the bottom of the loop using this pattern. So when we're done with all of these, we're going to print one line, and I've gotten a little fancier here than I used to. I did a little bit of a refactoring here. Um, it says the sum of entry count, so that's going to give us how many entries we have so far. And then I'm going to print entry if the count was 1 and entries otherwise. And I don't usually get that fancy, but in the Beyond the Textbook lecture for the last chapter, we looked at this ternary if, and I just wanted to show it off a bit. Okay, and then we say is sum of entries. And that's how that works. Okay, so we're using a lot of our good practices. And even though we're reading from two places, we have extracted a method such that we only see the details of how we prompt the user. We only see it in one place, this get input from user function. Okay. Now, I'm pretty happy with this solution, but it doesn't protect us from accidental non-integer inputs from the user, and that's not very hard to add. So here we're going to bring up O8, recovering from bad user input using while. Okay, and this is essentially the same design with just a little bit of extra code, right? So let's run it to see how it's got more functionality. So again, if we get enter on the first entry, we're just going to say 0 entries, 0 total. If we get 1 entry and then we stop, well, we're going to get the proper count and total. And if we get 3 entries, 111, 222, and 333, and then plain enter, that's going to work fine. But the interesting thing here is in this program, at any point, the user can give us a wrong entry. So they might give us, instead of 111, they might give us 1.11, okay? And it's going to catch that exception. It's going to say an integer value was expected, you entered 1.11. And then it prompts again. Okay. Okay, so what happens if we stop here? If we stop here, it hasn't counted the bad entry and it hasn't accumulated it. And that's what we want. Okay, so what if the bad entry happens uh, in the middle of a string? So we say 111, 222, hi mom. It tells us we entered hi mom, 333, then just enter for stop. And again, it only counted the three entries and it only accumulated the three entries. We got an accurate result. So this is pretty much getting to my final solution for an adding machine. Okay. And how did we change the code? Well, this is pretty much the code that we had in the last version, except we have put the work in the body of the loop into a try except block. Okay. So what do we put into the try? Well, um, the call to the prompt, right? No, I'm sorry, it's not the call to the prompt. It's this uh, call to int to convert whatever string we got back from the user. Okay, so even if we got a bad input from the user on the first entry, we're not going to try to use it till we're down here inside the try block. Okay, and then we bump up the entry count and then we accumulate it. What do we do if this blows up? This is the code that's going to blow up if we don't have a proper int. Well, we're going to print an integer value was expected. You entered entry as string. Okay, we're not going to count the entry. We're not going to accumulate it. And then we're going to come right back to the bottom of the loop and prompt the user again. So it's really pretty nice. Okay, and then when we're done, we're going to print this same result, including this a ternary if that gets the agreement between the number of entries and whether we say entry or entries. Okay, so not a lot of extra work. This pattern really lends itself to just a little bit of enhancement to catch bad input. Okay, and now I think we've finally gotten to a standard of usability. Now, admittedly, conversations with the user at the console are probably not the best idiom for user interaction. Some kind of more graphical user interface or web solution is probably more user friendly. But if we're going to work at the console, we've pretty much got to the pinnacle of uh, usability here. Okay. All right. So let's close these fellas and go on to the next one. Okay. So uh, our next use case is searching a file for a matching value. And I say a file here because uh, you could use the approach that we're using here to search in a list or to search in a tuple or to search in a string. But those types are implemented with classes that include methods that help you find values. Okay, so if you're going to find a value in a string, a list, a tuple, those kinds of things, you're probably going to do well just call the method for that type that's going to help you find it. You don't have to code that yourself. But there's no similar method for a file. Okay, and maybe you're working with maybe you are working with a list or you're working with a tuple or something like that, a string, and it turns out that all the built-in features aren't working, and you're going to have to write the code yourself. Okay, well then it's going to work a lot like what we're doing here for files. Okay, So when we're searching for just one match in a file, we want to stop when we get to the first match. Finding the match is finding a sentinel value. So the same kind of pattern that we use for flexible for the use case of flexible interaction at the console is going to work here as well. So we've got two versions. Um, the the conservative version, which is using the while and the sentinel pattern. And then one that I show you that uses for and break that is not conservative coding, but some people like, and I decided to share it with you. Okay, so we're looking at 10 and 12. Okay, so let's see what this looks like. Okay, so we're looking for three. Oh, let's look at the doc string. Demonstrates searching file records using while. And here's the detail line. Searches input file for a line containing three matching integers. And I generated a file. Let me open it up. It's called 3values.txt. I generated a file with 1,000,000 lines. Okay, so in each of them has three integer values. Okay, and I think the highest of these is, I think they go up to 1,000. Okay, and here we are. So if we go all the way down to the bottom of the file, uh, line 1,000,001 is just the line feed at the end of the 1,000,000 line. So one thing that is kind of interesting is just how quickly we read the file here. That'll be fun to watch. Okay, so I've got three versions of the input file that I'm going to show. I've got one that has 1,000,000 lines, and there's a match somewhere along the way. I didn't know what the match was until I found it with this program. Okay, it turns out we're about a fourth of the way through. I think we do less than 250,000 lines. We do them pretty quick. Okay, so now I had a version of this program that had an error in it, and it would run into problems if the last line was where the match was. So it turns out that the matching line that we're going to find has 896, 896, 896. And again, that's before we get to 250,000. Okay. Well, I made up a file that I call tricky3values.txt, in which I made that I only have 10 lines, and the match is on the very last line. And I had a bug in an early version of this that ran into trouble when that happened. Okay, so and it wasn't adequately tested. When I adequately tested it, I found the problem. And then we have the classic empty file.txt, which is just empty. Okay, so let's come back here. Before we explain the code, let's run it and see how it behaves. Okay, so please enter the input file name. Let's start out with the empty file.txt. So no matching values were found in 0 lines. Okay, well, it was empty. We're not going to get a match. Okay, so let's do the big file. That one's called 3values.txt. It says there are three matching values of 896 were found on line 216,000 and change. So out of 1,000,000 tries, we got three that matched on. It took us less than 250,000 records. Pretty good. Okay. And I just want to say what happens if we give it a short file. I call this tricky 3values.txt, and it found it on line 10. Okay, so that's how it works. Um, how do we do it? Well, it's a classic Sentinel value, right? So we uh, we prompt the user for the file name and we open the file. Okay. Uh, we're going to count the lines so we can use that in the output. Okay. Um, one thing that we do, and this is a good use of Booleans, it's very helpful when we're looking for things or we're looking for some kind of end condition to just create a Boolean um, to represent that condition. So here I've created one called match found, and its initialized value is false. And here I do my priming read. Okay. And again, this is the typical thing. So we do a priming read at the end of the initialization, and then we do another read at the bottom of the body of the loop. Okay, and in prior versions of this, I just had the two reads. I thought that was fine, but I've decided to clean this up and get rid of duplicate code. So I extracted the method and I call it read a line. Okay, and when you're reading a line from a file, you have to know what file you're reading from. So you need to pass the file object, and that makes it a little clumsier to factor out this common code. But one of the interesting things is, PyCharm with its refactor extract method was able to do all that for me. So I think that was a pretty good thing to do. Okay, so we begin with a priming read, and now um, we have a while loop, and I've got two conditions. Okay, and it's important to think of this as a process that can end two different ways. Okay, it can end by coming to the end of the file and not having found what we're looking for. Okay, that's going to end this while by line being equal to the empty string, because that's what happens when we do a read line. Okay, and that's the thing that we've got when we do a read line. Um, um, when we read the last line, we get the data from that line, and when we read again to signal that the end of file has happened, it gives us back the empty string. Okay, so we want to quit when we get the empty string, because if we read again, well, some things blow up, other things just give the empty string back again, but you don't want to read past the end of the file. And the other is, what if we found a match before we ran out of lines? So we're saying we're going to continue this loop until we either run out of lines or we find a match. Okay. And so we bump up the line count. We do a split. Okay. And then we convert the three integer values that are strings, we convert them to ints in a cute little loop here. Okay. And then we do a compare. In this, I'm sorry, we haven't done the compare yet. We had them in a string and then we want to unpack them. Okay, so we unpack them into first, second, and third. Okay, because values is a list of ints. Okay, and then we ask if first equal second equal third, and this is one of these chained comparisons. And I've seen this feature misused a number of times, but this is a great way to check if say 3 or 4 or 5 things are equal, or if they're in ascending order. you can just chain the comparisons. It's a very nice Python feature. So if they're equal, we found a match. Okay. So we set match found to true. Okay. We're going to use that in two different ways. Okay. Uh, uh, One way is that we're not going to go around the loop again because match found is going to be equal true. Okay, so that sets up the exit from the loop. Okay, and then of course we have a match, so we print three matching values of first. They're all the same, right? So just pick one. We're found online, and then we have a line count. And because we have so many lines, I formatted it with the comma separators so that when we run it and we're up to 216,000 lines, you can read that value easily. And then, of course, at the bottom of the loop, uh, we read the file again. Okay, so we've come out of the bottom of the loop. They're one of two possibilities. Possibility one is that we have found a match, and possibility two is we have not. Okay, so in any case, we should close the input file because that's the polite thing to do. And if we've already found a match, then we've already printed the answer. But if we haven't, well, now we need to say that we didn't find it. Okay, so the second use is that we check it here. Okay, could you design this a little differently and print one of the messages or the other out here? Yeah, you could. And in fact, I think we'll probably see students doing that when we do a similar problem in class. And that's it. So how do we get out of the loop? Well, we're going to continue around till either we find our match or we run out of lines trying. Okay? And then we just have to know which it was when we're done. And that's where this setting up a Boolean that's kind of an indicator is a great idea. You initialize it to false, and when you find a match, you set it to true. Okay, so that's the classic how to find the first match in a file. And the beauty is, okay, you stop reading the file when you find the match. So here we had a million lines, and we had to read less than a fourth of them to get the job done. Okay, so we come out of the loop and we just close it. We haven't read all the records, okay, in that case, because we found the match on record 216,000 and change. But we're done. We close it. So you don't have to read all the way to the end, like you would think you might have to do if you were doing a for in, because the basic processing for a for in is to read every line in the file. Okay, so let's look at another solution, okay, that again is a little bit controversial for some people. I'm a pretty conservative programmer, so it's a little controversial for me. It might not be for you, okay. So we're going to do the same work, okay, and let's run the test, but we're going to use, instead of the while, and instead of the while, we're going to use for in and break. Okay, a lot of people don't think of that, but it can be done. So let's do some testing first. Okay, so we're going to run this. It should run the same as the last one. So let's run empty file.txt. No matching values were found in 0 lines. Okay, and let's do 3 values.txt. And it says 3 matching values of 896 were found on line 216,000 and change. That's perfect. Okay. And let's do a tricky three values dot text. And it finds it even when it's on the last line. Okay, that's great. So how is this program different? Well, um, it doesn't it doesn't use a while. Here's what it does. It does a for in, okay, which really sets us up to read every record, okay. It does the same thing in terms of setting an indicator to say whether the match has been found. So its initial value is set to false, okay. When we find the match, we set it to true, and uh, the message that says what we found and where we found it. But then we call break. Well, then we don't call it. It's just a keyword. It's not a function. So then we execute the break statement. And break, as we talked about in the Zelle chapter, uh, breaks you out of the loop. So it just jumps out of the loop. The loop is over. Okay. Well, what about the rest of the records that we haven't read? Well, we're not going to read them. Okay. And then we close the file. And then we've got the same job here. We still have to be able to print the message if uh, the value hasn't been found. Typically, that's going to happen when we get to the end of the file and we haven't found a message. Okay. So is break a good idea? Well, there historically were people who didn't like break, and I was one. Okay. I worked in a couple of shops where uh, we weren't allowed to use the equivalent of break in that language that we were using. Um, there are probably still some places where they say that. There's plenty of good programmers who use break, and you can feel free to use it. Okay. Uh, but this is kind of, it's almost like cheating, right? You set yourself up to read all of the lines, and then you quit. Uh, you quit early, okay? Which is essentially what the other logic does, but it's more homegrown. Okay, so let's close all these before we move on to the next one. That was searching a file for a matching value. Okay, so the next one is kind of hypothetical for us. Okay, it's processing records from a data store that does not support for in. Okay, so what's a data store? Well, a data store is persistent storage for data. Now, the only data store that we cover in our course is the file. Okay, and we access it with the Python file type, which is implemented with the Python file class. Okay, and we've learned a lot about it. Okay, now it turns out that the Python file is an iterable, so we can use for in with it. It works just fine. Okay, we've already seen that you don't have to because um, in the first of the solutions that we did for um, finding the first value match in a file, we used readline, and readline is not one of the iterable features of the file object. Okay. Now, there are other kinds of data stores. There are databases, right? There are, and in fact, there are all kinds of databases. There are web services from which you get back a stream of results. Like when you're working with the Twitter API, okay, you send a request to Twitter to say the tweets that you want, and you get back a stream of tweets, right? Now, I think at least in the initial thing with the Twitter API, there was no iterable that you could use to do a for in over the tweet object, the tweets object that you got back. I think there is one now, and I think there's been one for a while, but there are all kinds of kind of web services like this where you're going to get a group of results back, and over time, um, the Python community writes classes that support for in, and that's fine. But before that, you have to know how to use this pattern where you're going to be reading from a data store, and you can't use for in. Okay, so we're going to use it on a file here, and we're going to use one of the methods of the file object that we used a couple programs ago, readline, which gets you one line of a file, and it's not using the iterable features of a file. Okay, so this is what we practice on. So now we've got three examples. Okay, two good examples and one cautionary tale. Okay, the last one is something I'm not going to recommend that you do. So example 15, processing data records using while. Okay, 16, processing data records using while with break. Okay, and this examples of how to do this, I think, were pretty well covered in the Zelle chapter, but I'm going to show it again here. And then the last one is using while and break, but it's also using a statement that's often thought to be a companion to break, which is called continue, which just is a very bad practice. So I'm going to show you, I'm going to talk about why it's a bad practice, and I'm also going to show you how easily you can avoid having to use it. Okay, so let's get started on 15. Okay. Okay. 15 is processing data records using while. Okay, so we're going to do something here that we've already shown in class, and we're going to do it in an assignment maybe this week. We'll see. So again, my doc string's a little too chatty. It's an instructor quality doc string. So do as I say, not as I do. Your doc string shouldn't be this chatty. So I say demonstrate processing data records using while. So we're going to transform records that have names, person names, in a natural order to records with names that are in a sort order. We've already talked about that in our class. Many data store technologies support reading data without using the for in construct. Python files support the readline method, which again is not part of their support for the for files being initerable. Okay. Okay, so we do all the usual stuff. We're creating an in file and an out file. Okay. And so we prompt for the names and we get them open, and we're keeping a line count. We initialize that. And of course, uh, because we're using the while, we're going to do a priming read. Okay. And again, when you're going to take a file read, which you do from more than one place, and you're going to refactor it and extract it into a method, well, then you're going to have to pass it the file object. Okay, so we have to pass in file here. And of course, when we do the read at the bottom of the loop, we have to do the same thing. And again, I had versions of this that did not have this factored out into a common function. Um, but I think this is a better practice, and I want to show you good practices. So I've done this. Okay. So in this case, all we're looking for is end of file. Okay. And again, uh, this would be the case on almost any one of these data sources that you can use that don't support, they're not iterables. Okay. Well, you're probably going to be calling some kind of function to get the data, but almost always they signal end of data by passing you back an empty string. Okay, so this is pretty good practice for something like that. So we say, well, line is not equal to the empty string, which means we haven't gotten to the end of the data. We're going to bump up the line count. We're going to split the names. We're going to format our content using an F string, and then we're going to print the content to file equals out file. And then, of course, we're going to do our read at the bottom of the loop. This is the classic while construct where you have a priming read and then the read at the bottom of the loop. When we get done, we have to remember to close both the in file and the out file, and then we're going to report the answers. Okay. Now, I probably should have run this to start, so I'll run it now. So I'm going to run it, and I've got, before we look at this, let's look at the data. So we've got person names.txt. This is going to be the input, and these are, I think, 125 names that I generated off of a fake test data web site that generates fake names. Okay, and I've used this in a couple of courses, so that's where the names came from. Okay, so that's always going to be the input. And then the output is going to be the same file. I'm sorry, it's going to be the same file in in the form that we call sort order, which is last name comma first name. Okay. I've done another trick here that I didn't really note when we're going through the code, and that is I've derived the name of the output file from the name of the input file. So I prompt the user for the name of the input file, and then I use that. But then I take then I create the output file by appending the in-file name onto sort order underscore. Okay, so the output file, we're going to have a sort order person names, and when we run this with the empty file.txt, we're going to create a sort order empty file.txt. So what I'm going to do for right now is I'm just going to delete the output file so we can kind of see what happens. Okay, do my file delete. Okay, that's that. So the person names is the input file. So let's go back here. We ran it and we're waiting for the name of this. So let's say person names.txt. Okay, and I typed it wrong. I did person name. I'm sure this happens to you, and you curse me for having such long file names. Person names dot text. Okay, so we say 125 records were read from person names dot text, and 125 were written to sort order person names dot text. Okay, and this is the thing I don't think we've done in our class yet, but um, one of the things you can do is to derive the name of your output file from the name of your input file. Okay, why make the user type something if they're always going to have a fixed naming relationship? Okay, so what happens when we run? Oh, and if we look in here, we go to sort order person names dot text there, and the right orientation. So that worked fine. And then let's do run this with empty file dot text. And it says there were 0 records, but we created something called sort order empty file dot text. And here it is. It's empty. Pretty good. All right. So so this is a pretty easy way to read a file. Okay. Could we have done this with a plain old for-in? Yeah, we could have. Okay. But we wanted to show you that we could do it without, so you can see the pattern that we use when we're reading from a data source that does not support for-in. Okay. So the file here is a kind of stand-in for something like that. Okay. Now what's the next one? Well, what if we wanted to do this with break? Okay. Now, what's the advantage of doing this with break? Well, the advantage is you don't have to do a priming read. Okay. So if you look at the bottom of all this initialization, there's no priming read. Okay. The only read that we have is the first line in the while. Okay. And the trick that we see here, and I think is pretty well covered in the Zelle book, is what we do is we do this bold thing is we say while true, which is an infinite loop. Okay. And we're expecting to only get out with the break. Okay, so we go around here, and as soon as we detect end of file, we break. Okay, so this is a little bit less conservative. Again, I worked in shops where you're not allowed to use break or its equivalent at the time. But I think most reasonable programmers think that break is okay, especially if you only have one break in a code block. Okay, so if you have some kind of loop and you break out of it in one spot, okay. I think it's also good if it's the only way out. Like with this while true and the break, we're never going to just fall off of the bottom of this. You know, this while true is never going to resolve on its own. Okay. So really, the complaint against the break historically is it created a block of code that had more than one exit. Okay. And this doesn't really violate this. This has one exit, but it's in the middle. Okay. Which I think is okay. And then we close the files and we do the printing. And is this better? For people who like break, they consider it to be better. Is this worse? Well, for people who want to avoid using a break, which probably includes me, um, then I would prefer to do it the way that we've just seen in the previous program. Now, what's right for you? Well, try them both and decide. You know, you're going to develop your own style. Okay, and when we test this, it's going to test just like the one before it. So if we say we want to give it person names.text, well, it's going to do 125 records into sort order person names text. And if we say we want to give it empty final.text, it's going to put 0 records into sort order empty file.text. Okay, so you pick your version of that. All right. Okay, and these will both work with data stores, some kind of data sources that do not support, that are not a Python iterable. So you can't use the for-in with either of them. Okay, you're going to have to be using some kind of while construct. So the issue between those two is break or no break. All right, now we've come to something that you'll see people do that I don't want you to do. Okay, so this is the same program, kind of. I've got a really chatty doc string, and it makes my point appear. So we're trying to demonstrate processing data records using while with break and continue to implement optional behavior. It's going to transform just a subset of the records in the input file from the natural order to the sort order. Note that it skips the first 50 records. Okay, that's why it has optional behavior. It doesn't do the same thing for all the records. The first 50 are not transformed. Using the break statement is a style issue. I said that just a minute or two ago. But using the continue statement is just a bad coding practice, although you'll see it used in lots of places. I don't know that it's used in the Zelle book, but it's used in several places in the Severance book, and I cringe every time I see it. Okay, so don't use it. Okay, why? Well, because I'm going to show you before we're done that the continue is easily replaced with an else. Okay, which we know how it works. Okay, so here's what we have here. We've taken just the last version of this program that converts the names from natural order to sort order. Okay, and what we've said is we just want to skip the first 50 records. Okay, so we got the same thing. We don't have our priming read. Oh, we're going to run it first to see what it does. Let's do that. So we run it first, okay, and what do we call it? Person names. Person names.text. Okay, so you can see we read 125, but we wrote only 75, which is consistent with having skipped the first 50. Okay, and can it handle an empty file? Well, of course. We sent an empty file.text, and it read 0. It wrote 0. So it's not fooled by an empty file, which is, of course, our goal. So what have we done here? Well, here's what we've done here. In this version, we've just added these 2 lines. Okay. So we say if the input line count is less than or equal to 50, continue. What does continue do? Continue, and I don't want you to think about this a lot because I never want you to use it. It jumps over the remaining code in the body of the loop. It doesn't jump out of the loop because we come around and we start the loop again. So it continue says, skip the rest of this loop and go up to the top of the loop and start again. Okay. Uh, so it's a way to skip code, jump over code. All right. Now, jumping over code was a common practice when I got into programming 50 years ago. It was just it had just become uh, a bad practice. Okay, so jumping over code was a bad practice 50 years ago. Okay, um, it was considered a good practice 60 years ago. That's how old this issue is. Really old. Okay. Um, so this works fine because we jump over the writing of the output for all the records that are less than or equal to 50. Okay, well, what could we do instead? Well, I'm going to do this in two steps. Okay, so if we have this if that checks for less than or equal to 50, what do we want to do? Well, we want to do nothing. There is a statement that I've been showing you from time to time when I create an empty function. It's pass. It's the do nothing statement. Okay, so if it's less than or equal to 50, pass. Else, and then just take all this stuff and indent it so that it's hanging on the else. Okay, first let's test this to make sure that we get the right results. Okay, all right, so we're going to run this. We're just going to do it with the real file, person names dot text, and 125 inputs, 75 outputs work just fine. And let's make sure it doesn't get fooled if we give it an empty file for input. Empty file.text. Yeah, it didn't get fooled. All right, well, why does it work? Well, how do we normally show optional behavior? We normally show optional behavior with an if or an if else or uh, a multi-way if, elif, else. Okay. So why in the world do we have to resort to a continue? Well, there's no way to do it. I mean, there's no reason to do it. It's just bad coding. Okay. But we have done something odd here. We haven't really shown this before. We have an if, and we say, okay, if the condition holds, do nothing else, do something. And you might say, that looks odd. So I say, oh, okay. Well, here's what we do. Let's just reverse the test. Okay. So we say if input line count is, so what's the opposite of less than or equal to? Well, it's greater than. Okay. Get rid of the pass and the else. Okay. That reads even better yet still because you don't have to think kind of backwards. Okay. And what's this thing doing? Well, it's only going to transform the records that are greater than 50. It's skipping the first 50. All right, that's great. So let's give that a test. It should work just the same. So let's say person records. Oh, what is it? Person names. Text. Out. Skip the first 50. And does it get fooled by an empty file? Empty file.text. It does not get fooled by an empty file. So I think this third version is the best. The intermediate one where we had the pass and the else, that's a quick fix, right? Okay. You can kind of leave things expressed the way that they are and just get rid of the continue very easily. But restating the if and just having the optional behavior hanging off of a well expressed if, this is good coding. And I have to emphasize again, there's no reason to use continue ever, ever, ever. It's a bad practice. All right, I'm going to get off my soapbox. What else do we have to talk about? Well, simulating gameplay. So we're getting pretty close to when we cover chapter 9 in the Zelle book. We cover, even though it's the next one in sequence, we do cover two other units before we get there. And in that unit, we design and build a game simulation program. And why do we do that? Well, there's a history in teaching programming that we teach game programs when we're trying to teach students how to design and implement a complex program. Because as complex as all the things that we've been doing so far are, they're we're essentially doing one thing in every program. And in game programs, you're doing a couple things at a time. You're keeping track of whose turn it is, you're keeping track of the score. There's a lot of opportunities to be doing things on several levels at the same time. Okay? So, uh, it turns out that because of the fact that games continue until one player or one team has won, it's a natural use case for a while. Okay, so I'm going to show you an easy game simulation program, easier than the ones that we're going to do when we get to chapter 9 in this 20 playing a game using while. Okay, let's give that a look. Alrighty. So, uh, what's my doc string say? Demonstrate playing a game using while, implements the simple coin flipping game. A player wins when they get heads and the other player gets tails. And so um, uh, each we have two players. We call them player A and player B. They each flip a coin. Think of it, well, it can be whatever kind of coin you want. And we have this idea of it has a 50-50 chance of turning up heads or tails. So if both of the players get the same value, if they both get heads or they both get tails, nobody wins. We just flip again. Okay, and we flip until one of the players has heads and the other player has tails, and the player who got heads wins, and the player who got tails loses. Okay, so how could you simulate this with a program? Well, we did a couple of interesting things. We're using a package called Random, okay, and I probably showed this before in the course. It's a way to get pseudo-random values, which is what we want here. And we're using a method, a function in the package called choice. So instead of giving us a number back, when we call the choice function and we pass it in a list of choices, it randomly chooses one and sends us that choice back. Okay. And of course, our choices are going to be heads and tails, and I decided that they were going to be represented by constants. Okay, so interestingly, you begin to see how why these game simulations are more complex. This is a three-level program. The main does the orchestration for the whole thing. We have a function called play turn, which plays a turn. And playing a turn is the combination of um, doing a coin flip for A and doing a coin flip for B. You can see that here, coin flip for A, coin flip for B. And then printing player A gets A value, player B gets B value. And then we return the results, A value and B value, to the main. And that, of course, is going to go back as a tuple. Okay. And we have created a function that just flips one coin. Okay. Instead of doing it twice, we have factored this out into common code. We've used the don't repeat yourself dry principle. Okay. And we're going to say we're going to return, and then we call choice. This is a choice from the random package. And we pass it the options heads and tails. And so it's going to pass back a randomly chosen either heads or tails. And then up here in the main, well, we print a message. Welcome to the simple coin flipping game. Uh, we play a turn. So this is a priming turn. So this is taking the kind of structure that we do with reading files or interaction at the console, and it's extrapolating on it and saying, well, we can have the same kind of approach to turns. So here's what we do. We have a priming turn in which we call play turn, and we get back the value for A and the value for B. Okay. Now somebody may have won. Okay. So here's what we say. We say while value A equal value B. So while we're tied, okay, play another turn. Okay. So if we get a winner on the first turn play, well, then we stop and we go back into evaluating the winner. Otherwise, we keep playing turns until they have unequal values, and then we figure who's the winner. So if value A is heads, then A is the winner, else B's the winner. And again, we only get here when A and B are not the same value. So we know that one of them is heads. Okay. And let's play this. Okay. Let's give it a run. So we played it the first time, and we got first, they both got tails. Then player A got tails, player B got heads, player B wins because the way that I invented the game, it's, my game, my rules. Uh, the player with heads wins. So now we play again. And look at all the ties that we got here. A tie with tails, a tie with heads, a tie with tails, and then player A wins. We're getting a lot of ties. And this is the simplest. A gets tails, B gets head, B wins. And let's see what we have a simple one where A wins. Oh, look at all those ties. A simple one where A wins. There we go. A gets heads, B gets tails, A wins. Right? So what I'm really trying to show you here is that the while is perfect for gameplay because we're going to play while we don't have a winner. Okay? All right. Almost done. So while loops are very good for controlling devices. And by devices, I mean machines, electronic devices, all those kinds of things that we have come to believe are controlled by computer. So it might be some kind of entertainment device. It might be a machine in a manufacturing plant. It might be a car or a part of a car, right? So when we're doing device control under the control of a computer program, um, it requires constant communication between the program and the device. Sometimes that's one way, well, it's always a two-way communication in some sense. Uh, because the devices are being controlled for an indefinite period, we usually don't say, well, we're going to drive our car for 5 minutes. Okay, or we're going to run the manufacturing machine. I guess we could say we're going to run the manufacturing machine for 8 hours or something like that. But what if somebody's arm gets caught in it? We probably want to stop early, right? While is the natural construct. So I've done some playing around with devices that are used by hobbyists. And I've done some device control with Python, and we use while. So I just wanted to show you that before we're done here. So that's 30 controlling devices using while. Okay, so what kind of devices are these? Well, uh, I wrote a program that animates this device that I'm using as a kind of a star on top of my Christmas tree. So let's see what that device looks like. And that came up on my browser. So I'm going to bring it over here. And this is a thing called a NeoPixel. Okay. And it's from available from a company called Adafruit. And Adafruit is a really cool company that is owned by, or was started by, and I'm sure is principally owned by, a young woman who calls herself Lady Ada. And the Ada is in honor of Ada Lovelace, arguably the first computer programmer. And so they have all kinds of devices for hobbyists and gamers and cosplay people and all kinds of things. And so this device has all these lights, and you're able to turn them on and off, each of these individually or in groups, and you're able to change their color and things like that. And how do you do that? Well, you have some kind of a microcontroller board, okay, and that is connected um, originally to your PC. That's how you download the program into it. And then later, you connect it to a power source, like oh, a 5 volt cell phone charger. And the program starts up, and these wires uh, allow the controller to manipulate these NeoPixel lights. Okay, and there are a whole bunch of these. Like this one looks like this, but we've got where are my NeoPixels? I love them. There's a ring, there's tape, uh, there are individual stick-on ones. There are just plain old LEDs. It goes on and on and on and on. And some of these things are, well, they're largely made for entertainment. Okay, and they're used by cosplay people. The entertainment that I use this for is to control the star on the top of my Christmas tree. All right. The next thing I want to show is the microcontroller that I was using last season. And this is a board that they call a Metro M4 Express. It's more, the chip in it is an ATSAMD 51, and it supports a standard called Arduino. And there's a lot of people who do this, hobbyists, uh, computing to control devices, who have used Arduinos for a long time. Okay. Um, so that's what I use to do that. And I gotta fix my mouse. And here we go. My mouse is fixed. And then the last thing I wanted to show you is what kind of Python we do this with. And there's a Python subset. Well, it's not only a subset, it's a superset. So there is an implementation of Python called Circuit Python. And it's based on a distribution that was created for microcontrollers called MicroPython, I think. And the company who's been the biggest supporter of Circuit Python is Adafruit. Okay, and so it's Python. It has a different group of libraries that come with it and then come with the Python 3 that we use. Okay, it has a lot of the libraries that come with our Python 3, but it has others, and in particular it has a bunch that you can use to control these devices. Okay, so back to my program. So this is a program that we use to control the star on top of my Christmas tree. And so we import a lot of packages, and probably I could have done a cleaner import by saying, from time import this, from board import that, from random import this. So maybe kind of raggedy code as far as I'm concerned. Then we have a bunch of constants. And constants are used by people who are doing this genre of computing to save the codes that implement certain colors and things like that. So we've got a bunch of those. And then we have a main, okay? And the first thing that we do is we initialize that the board that controls the neopixels, okay? And then we go right into a while, okay? And we just say while true, okay? And here's what I do. I've created 4 functions. One's called animate star swirly, so it makes swirly looks on the star. Animate star twinkly, that makes a twinkly look. Animate star inflate deflate, it looks like it just blows up and that it deflates. And animate star twirly, it does kind of a twirly thing. And I'm passing the NeoPixels board, and I'm passing 120 to say do it for 120 seconds, which is 2 minutes. So the star goes swirly for 2 minutes, twinkly for 2 minutes, inflate, deflate for 2 minutes, twirly for 2 minutes, and then it comes right up here. And so you may say, Kevin, where's the break? And I'd say there is no break. So one of the interesting things is in this genre of programming, these devices just run until you unplug them. Okay, so we're not even testing, has somebody pressed the stop button? Okay, people just unplug these. Okay, so here's a while true that runs until you unplug the damn thing. It's incredible. Okay. And how do I learn all this? Well, there's a cool book about how to do this. There are several books that they have at Adafruit. Let's go back to Adafruit. These guys are super fun. And go back to Adafruit. If you go to Learn, there's this kind of learning blog and fun projects, and they point you to books and blogs and articles. And the next thing you know, you spent, well, you can get started pretty cheaply, right? But the next thing that you've spent a whole weekend, and that's all you've done. Okay, so that's that. Okay. Um, so I just want to go back and remind you, which is the thing we don't always remind you of. Let's just go back to the slide from the beginning. Okay. The go-to looping construct in Python is the for in. Okay. It's only when it's not appropriate for your use case that you do things with while. Okay. And these use cases that I've talked about in this Beyond the Textbook lecture, uh, they're the use cases in which you probably want to dip in and use the while. And of course, you have the issue when you're using the while. Can you use the break? Okay, and that's a style issue. Only you can decide for yourself. It's more conservative to stay away from it. It's more radical to use it. Okay, but you'll decide what kind of programmer you are. But never, ever, ever use the continue, even if you see it in books and articles and Stack Overflow and wherever. We don't need to use it. It's bad coding. They ought to take it out of the language. And with that, I'm going to say bye until next time. Bye bye.